So in this lecture, we will study a variation of queues, which is called priority queue. So what is a priority queue? A priority queue is a collection of elements such that each element has been assigned a priority, and the order in which the elements are deleted and processed comes from the following two rules. The elements of higher priority is processed before any elements of the lower priority. Okay, so that is for processing you must delete that element from the priority queue, right? It means that this rule defines the order of deletion. Okay, so when you go to delete an element from the priority queue, you will delete the element with the highest priority. Okay, and if there is a clash over priority, that is if two elements has the same priority, then those two elements are treated in FIFO order, first in first out. That is, the element which has arrived first will be processed first. Okay, so it means that if two elements have the same priority, they are treated in FIFO order, and FIFO means a normal queue. Okay, so if you assume that all the elements has the same priority, so it means that those all elements will be treated in FIFO order, right? First in, first out, which is the same as queue, right? Okay, so if all the elements have the same priority, then the priority queue is same as the normal queue. And if the priorities are different, then the element which has the highest priority is treated first, is processed first, right? So the priority queue is a variation of queue in which we have an extra element which is called the priority, and the order of deletion depends on the priority value, right? Okay, the priority queue can be of two types: ascending priority queue and descending priority queue. In the ascending priority queue, we delete the lowest priority element. Okay, when we go to delete an element from the priority queue, the lowest priority element is deleted first. Okay, and in the descending priority queue, the highest priority element is deleted first, right? So ascending priority queue, the lowest priority element is deleted. So as we go on to delete more and more element, the priority of the deleted elements increases. So it is called the ascending priority queue. And in the descending priority queue, we first delete the highest priority element. So we go on to delete more elements. The priority of the deleted elements decreases, right? So it is called the descending priority queue. Okay, so what is a priority? What can be the priority of elements? Priority can be defined intrinsically. That is, it can be based on one or several fields of the element. Okay, so for example, your element is an integer. Okay, so the value of the integer can be considered as the priority, right? So say you have this list 4, 5, 8, 10, right? 15. So this is a queue. Okay, and you are using the value of the element as the priority of the element, right? So it means that the priority of this element is its value, that is 4. The priority of the second element, which is 5, is 5, right? Okay, so what will happen in this case? The priority of the elements are defined intrinsically, and it is equal to its integer value. Okay, and similarly, if your elements are strings, okay, then they can also be ordered alphabetically. So uh, they can be defined intrinsically as the priority, that is, the value of the strings can be used as the priority. Okay, so it means that consider this example of integers. So this is a queue, and say you use ascending priority queue. In the ascending priority queue, lowest priority element is removed first, right? Okay. So if you use this queue as ascending priority queue, the lowest priority element. So lowest priority element is this, which has the lowest value. Okay, we are using the element value as the priority. Okay, so this element has the lowest priority because it has the lowest value. So it will be deleted first, then next 5 will be deleted, and so on. But if you use this queue as descending priority queue, then the highest priority element will be deleted first. So in that scenario, 15, which has the highest priority, will be deleted first. Then the next element to be deleted will be 10, and then 8, and so on. Right. So similarly, if there are integers, you can so if you have a string values, since strings can also be ordered alphabetically. Okay, so they can string values can also be used as the priorities, right? So what can be what values can be used as priority? Those values which can be compared, because we have to find the highest priority or the lowest priority. Okay, so we must have some method to compare the priorities. So any value which can be ordered using some criteria can be used as a priority. So priority can be defined intrinsically. Okay, that is it is based on it is based on either one or several fields of the elements. Okay, for several field means, for example, say you have a telephone directory. Okay, in the telephone directory you have the name of the person. The name can be further divided into the first name, the last name, or the first name, middle name, or the last name, right? And then the phone number, the address of the person, right? So the telephone directory can be ordered by the last name. Okay, so you can use the last name as a priority, and then say you want to process the next number in the telephone directory, and you can define the telephone directory as the ascending or the descending. So if it is implemented as the ascending priority queue, then in that case the lowest priority. So it means that the name which starts from uh, A, the letter A, the names which starts from the letter A will be treated first, processed first, right? Okay, so intrinsic representation means priority can be defined intrinsically, that is, that they are not defined externally, but some value, either one field or several fields of the elements are used to define the priority. Okay. External priority, in the external priority, an external value is used which defines the priority of the element. Okay. So for example, say the value of the element is 4, and we use, okay, instead of taking integers, say the value of the element is a, small a, and its priority is 4, right? The second element is b, small b, and its priority is 2. Third element is e, and its priority is 5, and so on. Okay, so in here the priorities are defined externally. We have used an additional number, additional integer. Okay, since the priorities are integers, so they can be compared. Okay, so elements are character and the priorities are integers. So in this scenario, priorities are defined externally, right? So anything can be used as a priority, right? So here we have used integer values. Some other data can also be used as a priority. For example, you can use the time of insertion of an element as the priority. Okay, so you insert an element into the queue. Okay, and you measure the time of insertion of that element, and you also store the time of insertion of the element with that element in the queue, right? So now if you use the time of insertion as the priority of the element, then you can view the stack as descending priority queue, right? And you can also view the queue as an ascending priority queue. Okay, so how the stack is an descending priority queue if you use time of insertion as the priority of the elements. Okay, so what is stack? Stack is LIFO. Okay, that is last in first out. The element which is inserted last is removed first, right? So if you implement a stack as the descending priority queue, so what will happen? And you are using the time of insertion as the priority of the elements. So the element which is inserted last, okay. So its time of insertion T of I will be the smallest, right? Okay. So the time of insertion of the last element will be the smallest. Okay. So in the stack, the top element, that is the last element, the last inserted element is deleted first, right? So this element is resetted and this element has the lowest value of time of insertion. Okay. So the in the descending priority queue, we delete, sorry, in the sorry, this I made a mistake. Okay, so in the stack, the top element has the highest priority. The top element has the highest value of the type of insertion. Okay, the top element is inserted last, so its time of insertion is the highest, right? So you delete the top element, it means you delete the element which has the highest value of time of insertion, or you delete the element which has the highest priority. Okay, and the queue which deletes the highest priority element first is called the descending priority queue, right? So stack can be viewed as descending priority queue. Okay, similarly queue, a normal queue, okay, may be viewed as ascending priority queue. Okay, as in the queue is called FIFO, first in first out, right? So if you use time of insertion as a priority, it means that the element which was inserted first has the smallest value of time of insertion. Okay, that is because that element is the oldest element, right? And the oldest element is deleted first, P4, first in, first out. Okay, so in the queue, we delete that element which has the lowest value of type of insertion. That is, we delete the element which has the lowest priority. Okay, and in the ascending priority queue, we delete the lowest priority element, right? So a queue may be regarded as an ascending priority. Okay, so it means you can say that the stack and the normal queue are special cases of priority queues. Stack is like a descending priority queue when you use time of insertion as the priority of the element, and the queue is a special case of ascending priority queue. Queue is like ascending priority queue when you use time of insertion as the priority of the element. Now, how can we represent priority queues? There are several different ways. Okay, first is using one-way list, one-way linked list. Okay, that linked list can be ordered list or unordered list. Okay, ordered list means the elements of the linked list are ordered by the priority values, not ordered by the element values, right? So elements of the linked list are ordered by the priority values, and unordered list means they are not ordered. Okay, so how the insertion will take place in the ordered list? Okay, since this is ordered list, you must find the proper position of the element. You will traverse the list starting from the first position and will find the proper position of the elements according to its priority, right? And what about the deletion? Okay, since the list is ordered, okay, so deletion is very easy. Okay, so if you are using the ascending priority queue, in the ascending priority queue, you delete the lowest priority element. The lowest priority element will be the first element. Okay, so the first element will be deleted in the deletion algorithm, right? And if you are using the descending priority queue, in the descending priority queue, we delete the highest priority element first. And highest priority element will be the last element of the linked list. Okay, so the last element, you go on to the last element and delete that element, right? So in the ordered linked list, the insertion is tough because you have to find the proper position of the element, but deletion is easy. In the unordered linked list, insertion is easier because the element will be inserted at the last element of the linked list. Okay, the list is unordered, so you can insert the element, you can insert the new element as the last element, so insertion is easier. But deletion is not easier because the list is unordered. You cannot search by the priority of the element. You must traverse the entire list searching for the element and its priority, right? So in the ordered linked list, insertion is difficult, but deletion is easier. And in the unordered linked list, insertion is easy, but deletion is complex. Okay. And the array implementation. In the array implementation, we can use either a single array to represent the priority queue, or we can use multiple arrays. Okay. Okay, single array can be ordered or unordered. Okay, like the linked list, we have each one has its own advantages and disadvantages. That is, if the single array is ordered, then the deletion is easier. Okay, because the element will be the first element or the last element. It depends on whether you are using the ascending priority queue or the descending priority queue. Okay, but the insertion is tough. Okay, because you have to find the proper position, and here in fact the array insertion is more difficult than the insertion in the linked list, because not only you have to find its proper position, but you have to make space for the new element. Okay, so on average half of the elements will be shifted up in the array. So here in the insertion in the ordered array is more difficult than the insertion in the ordered linked list. Okay, and in the unordered array, the deletion is difficult because you have to search the entire array. Okay, and sorry, in the unordered array, insertion is easier, right? Insertion is easier because the new element can be inserted as the last element of the array. Okay, the new element will be inserted in the last empty position of the array, right? And the deletion, for the deletion, you must traverse the entire array searching for the element value and its priority, right? We have to match both the element and the priority, because we can have two elements with the same value but different priority. Okay, so the element values are same but have different priority, so these two elements will be treated differently, right? So while searching for the element, you must match both the element value and the priority. Okay, and the second scenario in which arrays can be used to represent the priority queue is the multiple array representation. That is, instead of a single array, you can use multiple arrays, each array for each priority value, right? So in fact, the array representation for the implementation and representation of the priority queue, multiple array representation are used frequently. Single array representation are not used because they are complex. Okay, so single array representation are not used until required in special cases. Okay, usually multiple arrays are used to represent the priority queue, and for the linkers representation, ordered representation is usually used. instead of unordered representation. Okay, so we will discuss the ordered one-way list representation and multiple array representation of the priority queue next. So first, linked list. So one-way ordered linked list representation of a priority queue. So each node in the list will contain 3 items of information: the info part, the link part, and now we have additional information, the priority. So we have a priority number, PRN. Okay. So now each node in the linked list has 3 parts. First part is the information, second part is the priority, and the third part is the link, which points to the next node. Okay. A node X precedes a node Y in the list if node X has the higher priority than node Y. Okay, remember we are using ordered list. We are discussing ordered list representation of the priority queue. Okay, so X precedes Y, node X precedes node Y if the priority of the node X is higher than the priority of the node Y. Okay, and when both node X and node Y have the same priority, okay, then we see that which element was added first. If node X is added first, okay, so X will come before Y. If node Y is added first, then Y will come before X. Okay, so when the both node have the same priority, but X was added to the list before Y, so X will precede node Y, right? So in fact, we have already discussed this. If the priorities of all the elements are same, then the priority queue is exactly same as the normal queue. Okay, elements are treated in FIFO order, first in, first out. So if node X and node Y has the same priority, okay, and node X is added to the queue first, so node X will precede the node Y. Okay, and if node X has the higher priority, then also X will precede Y. Okay, so this is how the one-way order linked list is used to represent the priority queue. An example, say this is a priority queue and it is implemented as a linked list representation, one-way ordered linked list representation. The elements are ordered according to their priority value. So this is the information part, info, this is priority, PRN, and this is the link which points to the next node, right? So the first element, this is the start of the linked list or the head. This is the first node. Okay, the priority is 1. Okay, smallest priority. Okay, so it means that this queue is ascending or descending. Okay, it depends on the users because this is ordered. So if you delete the first element, it will be ascending priority queue, and if you go on deleting the last element of the list, it will be descending priority, right? So okay, you can see that the elements are sorted according to the priorities. The second and third node has the same priority, okay, too. So it means that the element B was added to this queue before element F, okay, because B precedes F. Okay, so another example with the array representation of the linked list used for the priority queue. Okay, so here we have 4 plus 3, 7 elements. Okay, so first element, the priority is 1. Second element, priority is 2. Third element, priority is also 2. Okay, it means that the element triple B was added to the queue before triple C. Okay, okay, the priority of the fourth, fifth, and sixth elements are also same, equal to 4. It means that the triple D was added before triple E, and which was added before triple F, right? And then the last element has the priority equal to 5. Okay, so in the array representation, since we have two information part, first is the information part which contains the regular information, and second information is the priority PRN. So we will use two arrays, okay, for storing info and priority, and third array for the link. Okay, so this is obvious. We have already discussed this scenario several times before. Okay, the algorithm deletion algorithm for the one-way order list representation for the priority queue. Okay, so delete the first node. Okay, first node has the lowest priority. Okay, so it means that you are using if you are using the ascending priority queue, okay, then you will delete the first node, right? In the ascending priority queue, you will delete the first node, and in the descending priority queue, you will delete the last node, right? So if you have to delete, if you are to delete the last node, so you must use an extra pointer which points to the last node, because in the normal list you don't have the pointer to the last node. In the normal linked list you have only the start pointer. Okay, so if you are going to use the priority queue as the ascending priority queue, then you need only the start pointer, because you have to read the first element, the first node. But if you use it as the descending priority queue, in that case you must delete the last element, so you can have an extra pointer which always points to the last node of the linked list. Okay, so deletion is a lot of easier. You have to delete one element, either first or the last. Okay, insertion. Okay, so say you have to insert a new element with value item and its priority equal to n. Okay, so what you will do, you will find the location of this insertion. You will find the location of the item whose priority is equal to n. Okay, so for that you will traverse the linked list until finding a node whose priority exceeds n. Okay, then you will insert item in front of x. You will insert the item before node x. Okay, okay, and if no such node is found, then insert item as the last element of the list. Okay, it means that in this scenario, the B scenario, the priority of the new element item is the largest, so it will be inserted as the last element. Okay, so deletion is quite easier. Only one step is required, delete the first element, but for insertion you may traverse the entire list. Okay, now array representation, and we will discuss only the multiple array representation of the priority queue because it is used frequently. Single arrays are not usually used for the array representation of the priority queue. So in the multiple array representation of the priority queue, multiple arrays are used and each array is maintained as the circular queue. Okay, so each array is maintained as the circular queue. Okay, what is circular queue? Circular queue, in the queue we have two pointers, front and rear. Okay, and the circular queue, after visiting the last location we visit the first location next. Okay, okay, so each we have multiple array and each array is basically a circular queue. Okay. So a separate queue is maintained for each priority value, and each queue will appear in its own circular array and must have its own pair of pointers front and rear. Okay, that's the definition of circular queue. That is, a circular queue has front and rear pointers, and after visiting the last location we go on to the first location, right? Okay, If each queue is given the same amount of space, then a two-dimensional queue, that is a two-dimensional array, can also be used. If the size of each queue is different, okay, so here you are using array. If we are using arrays of different sizes, okay, then obviously we must define multiple arrays of one dimensions, okay. And but if we have to use the same amount of space for each priority queue, then we can also use a two-dimensional array, okay, and each row of the two-dimensional array can represent one priority queue, right? For example, this here we have five unique priority values, 1 to 5, okay. So in the multiple array representation, for each priority we use an array, right? So there are five distinct priority values, so we will use five arrays, okay. So we can declare five different arrays of different sizes, okay. But usually what we do, we use two-dimensional array. We use a single two-dimensional array, assuming that the size of each priority array is same, okay. So here in this scenario, we are using a two-dimensional array of size 5 into 5, okay. The number of rows is 5 because there are 5 distinct values of priority, okay. So this first row of the two-dimensional array Q, the name of the two-dimensional array is Q. So first row of the queue is for the priority value 1. The second row is for the priority value 2. Third row is for the priority value 3. Fourth row is the priority value 4. And fifth row is the priority value 5. Okay. And the size of each row is also fixed, obviously, because this is the part of the two-dimensional array, that is equal to 5. So 5 into 5. 5 rows, 5 distinct priority values, and the size of each priority queue is equal to 5 also. Okay. Now each priority queue, okay, the two-dimensional queue array has 5 queues, okay, 5 one-dimensional queues, and each one-dimensional queue, each queue has 2 pointers, front and rear, okay. So the value of the front pointer for the first queue, that is which is associated to the priority value 1, is 2, and rear is also 2. Front and rear are both equal to 2, and which are not equal to null, not equal to -1 or 0. Okay, null value. It means that there is a single value in the priority queue, and that is double A at location 2. Right? In the second queue, front is 1 and the rear is 3. Okay. Third queue 0 0, it means this queue is empty. There is no element with priority equal to 3, right? And the fourth queue, front is 5 and the rear is 1. Front is 5 and the rear is 1. In fact, this is wrong because here we have the first element at location 4. So front is 4 and the rear is 1, right? And the fifth queue with priority 5, okay, this is also wrong because we have the only one element at location 3, at index 3. So this is 3. Front and rear both equal to 3. Right. So in the multiple array representation, you can see that we use a two-dimensional array, and each row of the two-dimensional array corresponds to one priority value. Okay. So it means that if we have n distinct priority values, okay, so we will be using a two-dimensional array of size n into m, where n is the number of distinct priority values and m can be anything, okay. So if you say that your average number of elements for a particular priority value is m, then you will be using n into m size two-dimensional array to represent priority queue. Deletion algorithm for ascending queue. So for ascending priority queue, what will be the deletion algorithm if you use multiple array representation? You will have to find the smallest element. Okay, and for that you will find the smallest integer k such that front k is not equal to null. Okay, so you are implementing ascending queue, so you will be deleting the element with the smallest priority, right? So you will find the smallest queue such that front k is not equal to null, right? And then you will delete the front element of that queue. Okay, so first find the k such that front k is not equal to null, and then delete the process the front element in row k of the two-dimensional array queue. And if you use the descending queue, then you will find the largest k such that front k is not equal to null, and then delete the front element in row k of the queue. This is the deletion algorithm. So it has two steps. First, you will find the appropriate queue, and then you will delete the first element of that queue. Okay, insertion algorithm. So you have to insert a new element with value equal to item and the priority equal to m. So priority is m. It means that this new element will be inserted into the row m. Okay, and each row is maintained as a circular queue, so it will be inserted as the last element in that circular queue. Okay, so to insert a new element with value equal to item and priority equal to m, you will insert that item as the real element in row m of q. Q is the two-dimensional array. Okay, so you will first go to the mth row and you will insert the new element item as the real element, as the last element. Okay, that is, you will increase the value of rear by 1. Okay, and if rear is equal to n, the last rear is equal to m. Here m is the size of the two-dimensional array, column size, right? So if rear is equal to m, then since this is circular array, so rear will be reset to 1 and the new element will be stored there. Okay, so the steps in the extension algorithm, you will go to the mth row and the new element will be inserted as the last element, as the rear element of the mth row.